2, 1.
Hello, I am Kara Bacon.
And I'm Sam Pollock.
And we are presenting the Game 2005 Game Physics Assignment 3, 2D Collision Detection and Response.
Okay, and I'll start us with a tour of the program in action. Here from the start screen, we have buttons available to take you both to Part 1 and Part 2. Start here in Part 1. See the basic functionality with the raindrops falling at random positions. And then we've got these IMGUI functions to change some of the variables. We can change the witch's health. We can change the raindrops in the bullet pool. We can change the rain period, changing the frequency they fall at. And toggle between mouse and keyboard movement. Finally, we have gravity, wind, and wind fluctuation, which affects the fall of the raindrops. And then next up, we've got Part 2, which is the bouncing ball. Here we have a bouncing ball, can be hit by the witch. And once again, we've got some IMGUI to change some of these variables. So we can change again the witch's control from mouse to keyboard. And then we can change the witch and ball mass, so witch down, ball way up. There we are. And the ball bouncing, which determines how much speed it maintains after a hit. We can change the shape of the ball glider. And finally, like gravity and wind once again can be changed. Okay, next up, I'll pass to Kira and we'll start taking you through the code.
All right, so for the first scene, the main challenge was creating an appropriate bullet pool for the bullets. Since it wasn't necessary in this project to make it generic, we simply created a pair of linked lists. You can see that in bulletpool.h. Yeah, there. For the active and inactive bullets. The spawn and despawn methods simply switch bullets between the two different lists. The resize method, on line 51, will draw first from the inactive list if it is getting smaller. If it's getting bigger, it'll simply add to the inactive list. In addition, we also had to remove the raindrops from the display list in the scene using the remove child method. Had to adjust that method to not also delete them. When resizing the number of bullets using IMGUI, we simply remove all of the bullets, resize the list, and then add the remaining ones back in. I also added a couple of gameplay features, such as wind and wind fluctuation, which are simply an acceleration along the x-axis using a randomized value and adding or subtracting it each frame. It's on line 79. Then, on line 20, health is simply an integer that, if greater than 0, uses a for loop to display an image multiple times. If it does reach 0, it kicks the player back to the start screen.
Okay, and now I'll show you how the bullet collision is working in the bullet.cpp file. And here we've got after there's a bullet collision check, we're running a circle check and checking the radius of the ball against the radius of the player. And then if they are colliding, that's where they determine new velocity based on the mass of each other. Then next up, we'll take a look at Part 2, and Kira will show you how mouse control works.
Okay, that's on line 28 of the brick scene. So, for mouse control on both scenes, I take the difference between the player's position and the mouse position using the global mouse position that accounts for when the mouse is outside of the window, STL get global mouse position, and simply multiply the magnitude of that vector by the strength variable to replace the player's velocity. This means that the player will never actually be completely stopped, but it does feel very good.
And
do you want to talk about polygonal collision now?
I'll show the bounce back real quick.
Yeah.
Here I've got the physics formula implemented for for a recoil from when the ball and the player hit one another.
That's
And-
conservation of momentum.
And the conservation of momentum. Yeah, and now let's take a look at that polygon.
Okay, that's on line 62 of ball.cpp.
There we are.
For the polygonal ball shapes, I create it by simply taking an angle and rotating around a central point using sine and cosine to obtain however many points in a circle the user can specify. Each point makes a line when paired with the next point, which can then be tested for collision using a line-line check. Or in our case, on line 157, we use a line-rect check. In this case, the whole collision function is a little bit large because we can also check if the player and ball have different shapes, such as a circle or a rectangle.
Okay.
I think that's all. Thank you.
That's it. Thanks for watching.